Hello everyone, in today's video we are going to look at some problems under trigonometric identities. But before we dive into problems and solution, I want us to focus on how to easily memorize the formula, because most of the times it's not like you won't be given these formulas in your exam hall, so you need to find a trick in order for you to memorize it so that you can bring it down maybe in terms of exam or test. So this is it, but let's get rid of these things here on the board and let's see how we can bring it off it. So this is something like very easy. It doesn't require a lot of work. The only thing you need to do is to understand the concept. So first of all, before then, I'm sure you're already familiar with SOHCAHTOA. We said we have the SOH, we have the CAH, and we have the TOA. And this is simply the sine, which is our opposite divided by our hypotenuse, and the CAH, this is cos, which is our adjacent divided by hypotenuse, and tan TOA, which is our opposite divided by our adjacent. So, but I'll try our best not to mix it. Let it be SCT, which is SOHCAHTOA. So the next thing you need to do in order to bring down your trigonometric identities, that is the formulas, let's arrange it this way. Let's say sine, cos, and tan. If you notice, this is the same arrangement: sine, cos, and tan, sine, cos, and tan. So next thing you need to do is to write CSC. CSC. And under this CSC, the first one is going to be cot, second one is going to be sec, and the last one is going to be cosecant. So next thing you need to do is to assume that this is 1, this is 2, and this is 3, and at the other point this is 1, this is 2, and this is 3. So but before then, let's get rid of this place so that we can explain properly. So before then, I think we're just going to look at just three things under the trigonometric identities, which is the reciprocal identities, the quotient identities, and the Pythagorean identities. But in this case, we're trying to focus on the reciprocal. So if this is tan and we said let it be the number 1, the reciprocal, like the opposite, is what is cot. In this case, if we take tan to be first, cot is going to be the first one, opposite to it. Sorry. Therefore, the value of tan is simply going to be 1 divided by cot. Okay, what about the second one? If this is cos, the opposite is going to be sec. If we draw our line here trying to join them together, therefore the value of cos here is simply going to be 1 divided by sec. And what about sine? Sine, let's say sine, let's assume we are using x, is going to be cot x, cos x, this is going to be sec x. So the next thing on the list is sine x, and in this case sine x is going to be 1 divided by cosecant x. So since we said this is the reciprocal identities, and reciprocal identities, this shows the reciprocal between trigonometric function. So there are two ways to get the reciprocal. It's either you do it direct by joining the cot and tan, sec and cos, cosecant and sine, or let's take this to be number 1, 2, and 3. starting with the first one, you can set, okay, in this number one we have tan x, and tan x, this is simply 1 divided by cot x. If you like, since our denominator is cot x, we can multiply both sides by cot x. This is simply going to be bracket of cot x multiplied by tan x to be equals to 1 divided by cot x. We are going to multiply everything by same denominator, which is what? Cot x. Notice that cot will cancel cot, and we will be left with cot x tan x to be equals to 1. And at this point, this is going to be cot x, tan is coming down, is going to be 1 divided by tan x, and this is our answer. If you notice, this tan x is the same thing as 1 divided by cot x, and in this case cot x is the same thing as 1 divided by tan x. This shows that we have proved the reciprocal. Let's take the second one. If you set cos x, this is simply going to be 1 divided by sec x. I'm focusing on the second one now. So multiply both sides by sec x. This is going to be bracket of sec x multiplied by cos x, which is equals to 1 divided by sec x. We are going to multiply, as we said, since we have put our sec x here, we are going to multiply the other side, that is the right hand side, by sec x. This is still going to be sec x. So notice that sec will cancel sec, we will be left with sec x multiplied by cos x to be equals to 1. And in this case, this is going to be sec x to be equals to 1 divided by cos will come down here, 1 divided by cos x. So we are left with 1. So in this case, let's just manage this place, alright. The last one is what? Is sin x to be equals to 1 divided by CSC. So we know that this is simply going to be, we are going to multiply both sides by CSC, which is cosecant, CSCx multiplied by sin x to be equals to 1 divided by CSCx, and we are going to multiply here also by CSCx. Notice that this will cancel this, and we will be left with CSCx multiplied by sin x to be equals to 1. And in this case, if the sin x is coming down here, we will be left with CSCx to be equals to 1 divided by sin x. Okay, this is the first one, this is the second one, and this is the third one. If you notice, the first one, since we are talking about the reciprocal now, and I think this is the longest method. After that, we are going to look at the shortest method. So if this is tan x to be equals to 1 divided by cot x, and after all this calculation, at the end of the day, we arrive with what? Cot x divided by 1 is cot x to be equals to 1 divided by tan x. Tan x, which is equals to 1 divided by cot x, became cot x is equal to 1 divided by tan x. The second one is cos x divided by 1 divided by sec x to be equals to sec x to be equals to 1 divided by cos x. Next one is we have sin x to be equals to 1 divided by CSCx, and at this point we have CSCx to be equals to 1 divided by sin x, and this shows the reciprocal. Let's look at another method. So, as we mentioned earlier, that this is reciprocal, and we have tried other way around just to prove, since we are using the rainbow method, so we can say it, okay, let's turn it the other way around. What if you decide to our cot to be first one and connect it with tan. In this case, it's going to be cot will be the subject of the formula, which is equals to 1 divided by tan. Or let's say cot x to be equals to 1 divided by tan x. What the next one is sec x. Join it with cos x. This is going to be sec x to be equals to 1 divided by cos x. What about CSC? If you take the last one, cosecant CSC x, which is equals to 1 divided by sin x. So, and if you look at it, this is first one, second one, third one. This is first one, second one, third one. We have already gotten the reciprocal. In this case, tan x is equals to 1 divided by cot x. Here, cot x is equals to 1 divided by tan x. The second one, cos x is equals to 1 divided by sec x. Sec x is equals to 1 divided by cos x. The third one, sin x is equals to 1 divided by cosecant. Cosecant is equals to 1 divided by sin x. So I think for this problem, we are done with the reciprocal identity. Let's dive in, get rid out of this, and check another problem. Okay, next thing I have on the list here is quotient identities, and this is simple. It's just 2 and you just have to have it often. In quotient identities, we said if we have tan x, this is going to be sin x divided by cos x. What about if we have cot theta? In this case, this is going to be cos theta divided by sin theta, which they look really similar. So the next thing on the list is in the case of quotient identities, we said this identity expresses the tangent function in terms of sine and cosine. So what about the Pythagoras identities? Pythagorean identities, this relate the sine, cosine, and tangent of angle in a right angle triangle. So let's look at the Pythagorean. In this case, we have, in the case of Pythagorean, let's write it down. Identities. We have sine square theta plus cos square theta to be equals to 1, and tan square theta plus 1 is simply going to be sec square theta. What about 1 plus cot square theta, and this is simply going to be cosecant square theta. This is it for this problem. So in our next video, we're going to look at some brief example and solution under this.